Good evening to everyone. Warm welcome to each of you to the second day of the Hardware Workshop series organized by IEDC AJC. Welcoming the speaker of the day, Dr. Godwin Raj D, speaking on the topic Embedded Systems and PCB Fabrications. Welcoming you, sir. We also welcome each of the participants to today's session. Once again, welcoming all of you. Starting off, I invite Merin to welcome our esteemed speaker.
Dr. Godwin Raj, having over 8 years of teaching and research experience in the field of electronics and communication engineering. His specializations are power electron devices and VLC design, high-speed circuit design, and hardware implementation for biomedical and lab-on-chip applications. He is a recipient of a Senior Research Fellowship from the Department of Science and Technology, DST, 2011 to 2013, Council of Scientific and Industrial Research, Government of India, New Delhi, from 2013 to 2015, and published 23 SCI publications and 12 international conference papers. Currently collaborated with Taiwan Semiconductor Research Institute on the project GaN-based hemmed device design and fabrication for space application. We welcome Dr. Godwin Raj to address the gathering and to conduct a much looked forward workshop session.
Thank you. Thank you. I'm welcoming all of you to this session, that is Embedded Systems and Fab Lab overview. So in this session, we are going to discuss about that lab facilities, whatever we have, as well as what are the probabilities there for a BTech student to go into the research level, not only to that project level. So how we can convert the project into a product level using an embedded system project. Or you can go for optical design or optical system product level. We are going to discuss in this sessions more detail about this particular one. So our lab is comprises of embedded system lab as well as an optical design lab and PCB fabrication lab. It was funded by DST, Department of Science and Technology. So it was started in 2019. So after COVID, we started to work from 2020. So I'm going to share my PPTs. Gradually we'll start. So the tools we have in this particular lab is more or some of the PCB tools are shown in the left side. This is PCB design software and UV laser engraving machines, PCB etching machine, exposure machine, pick and place machine, stencil printer, and reflow oven. And I'll show that machines and how it is working in a real time over a time. So the other tools are, we have this FG function generators, which is having high resolution CROs and components, which is have. And regarding this flexible PCB lab, we have ink print machine and Hall effect measurement for the characterization of the samples we study, and conductivity and resistivity measurement unit, and nanovoltmeter, especially for low power measurement tools. So regarding the optical lab, we have this Raman filter unit that is for study this Raman signals, and we involve this optical spectroscopy that is very essential to mingle with this Raman edge filters. So these are the main common tools we are having in our laboratory for research as well as product level development purposes. So regarding the software tools, we have this Intel Quartus tool that is for FPGA programming, and that is have a license up to 2031, and we have this Altair Embed tool, and it is having license up to 2030. So along with that, we have this university program that is very important for our students to make them involved in this program, especially for Intel program, academic program is called Intel University program, as well as we have this Altair University programs along with this Embed. And also we have the ZMAX Optical Studio University program that is very essential for an optical design, especially design of an optical tool for specific applications. We have a spectroscopy or pesticide detector, something like COVID detectors recently, which is very big renown. Okay, so I don't want to go into much overview. Just I want to go into the basic, which is very essential for a programmable boards. Generally, people or students are using this board, which is most commonly these four type of boards they will use. One is the microcontroller based board, which is maybe with Arduino, Raspberry Pi, or Pico boards, or whatever it may be, which is board based on microcontrollers, which is using for a specific design and to do specific jobs. And second thing is the FPGA board, which is the programmable boards using for a high number of logic gates. So we want to go for in-depth study and even implementation of some complex circuits, especially we can go for this FPGA boards. And third one is a flexible PCBs, which is very, very essential in nowadays when you go to the hospitals or when you go for some of this medical tracking, real-time study, comfort with our skin, so flexible to monitoring of health in real time while jogging or walking. So that all comes under this flexible PCBs. That is basically very booming, and I'll explain how to make your tools in this flexible PCBs. So the fourth one is the ASIC PCB, that is from idea to the application. That PCBs are especially designed for the specific application. We cannot able to edit that particular PCBs. We cannot able to program. Once it is programmed, it is specifically programmed for the specific application. Second one is that people are going for an optical hardware design. So optical hardware is basically a combination of PCBs as well as optical devices. So more combinedly, we'll go for this particular tools. So when you're talking about a general microcontrollers, specifically more commonly we are using to do the specific task, which I shown here, which is maybe comprising of Arduino, Raspberry Pi, or maybe Arduino recent version boards. Raspberry Pi recent version is a 4A, 4B. So whatever may be the versions, it's all works for a specific logic applications, and we're having some limitations, especially in the clock frequency side. And when you see about Arduino, you can do specific functions, but it is very limited. But if you go for Raspberry Pi, it is work very similar like a system level, but it is limited in the memory, limited in the RAM, limited in the many aspects. So when you go for microprocessors are basically designed for video editing, gaming development, which we use in a routine life applications. So microprocessors are real devices. More often we will use in our applications rather than the project level. So these microprocessor devices are comparatively complex, and these can work nearly high frequencies, go more than 1 gigahertz, like even 2.2 gigahertz. Nowadays, the recent microprocessors we have worked with this dual core, octa-core. So that is a 8-core processor. Even 8 parallel processors are there in that. It can able to work for a specific applications. But when you go for microcontrollers, it will work only for 30 and 50 megahertz. In some cases, even bit also it is possible, but higher frequency microcontrollers are but expensive. Okay, so in place of microprocessor, we can use microcontrollers, but it will not get the efficient performance like. But the price of the microprocessor very expensive. So the microprocessor comprising need external components, because only a microprocessor cannot be able to be used. So you need to have some add-ons or add-on tool which has to which will compatible with this microcontrollers, microprocessors, and it is have huge power consumption is the secondary disadvantages of these microprocessors compared to the microcontrollers. So again, so the microcontrollers basically use an Harvard architecture, which is for specific programming informations memory, whereas the microprocessor having a Van Neumann model, which is having the memory is stored in the same place where in the programming. Okay. So when you come to this FPGAs, so FPGAs basically, as I told you, this is a field programmable gate array. So where we can configure any circuit using FPGAs, like if I want to implement a processor, a CPU. So I can use a FPGA for implementing one CPU. Like I want to make a GPU. So I can go for an FPGA to implement one GPU. So something that you can able to compatible with any real-time hardware. Like I want to have one memory device, I want to have one processing tool, especially CPU or GPUs. You can definitely go for FPGA for an application in that level. So some of the common FPGAs in many different forms. Like this is one of the FPGA which is called Intel Arria 10, which is integrated in Intel Xeon processor. And this is another form of FPGA which is used in a memory device or storage. This is another form of FPGA is used in networking devices. This is another form of FPGA which is implemented in a PCI or PCI devices. Okay. So the another difference from CPU and GPU we can able to make is CPU and GPU, which is hardware, is a fixed. Once it is a program, we cannot able to edit, we cannot able to change it. So it is a right program. So FPGA hardware is not like a fixed one. It is a general purpose. We can reprogram it, we can erase it, we can change it. But generally, ASIC devices or ASIC hardwares are using in a CPU for specific processor designs. So FPGA based processors are rarely used, but CPU general based or ASIC based more oftenly used in nowadays, especially in the mobile processors also. This is the same criteria. Okay. So again, the performance wise, we can say GPU level performance we can able to is high in the 10 times very efficient, but the power consumption also we can have to consider. Okay. So this is the analogy of a CPU or GPU comes with the fixed circuit. So this is a CPU or GPU in a fixed circuit, and this is what you will see. This is a FPGA. So it will be there in the different form. Like you want to have according to the logic you want, according to the processing speed you want, according to the number of elements you want to choose, and a number of interconnects you want to choose. So according to that you can choose this FPGA IC. So doesn't mean it is limited for FPGA is limited only for a specific ICs. Many number of FPGAs we have, even a smallest size FPGAs we have. So even with this you can able to build a CPU or GPU even with the breadboard. That is also it is possible. Okay, this with this analogy. So ASIC is something like, as we discussed earlier, so there's the application specific integrated circuit is dedicatedly built for the specific application. Means once it is made, we cannot able to change it, especially the special purpose application like Bitcoin miner and neural network accelerators. So these are some of the examples of ASIC, and we cannot able to change it. Okay, we cannot able to program it, reprogram it, and it is once exponentially built, we cannot able to change it. So FPGA based something is we can able to reprogram it, and we can able to change the programming using VHDL or very low. So that can able to done according to the number of logic elements, number of programming you are using, number of interconnects you are using. You can able to change everything. So that is possible. And compared to the other, ASIC is bit faster and it will have much higher efficient because it is needed. It is loaded for a specific application. It will be much higher speed compared to this. Okay. So here I am using this language for ASIC or in VLSI design is maybe hardware description language, which is very essential for an FPGA, and that is a register transfer level languages, which is need to program this hardware description language into this particular chip. So these programming languages, what we are going to do is Intel Quartus tools. So Intel Quartus tools basically are using to program this FPGA boards. So it will able to program. Most often we are using that Intel based FPGA, like we have a Cyclone and Statix. So there are some of the FPGAs which is limited with Intel, but doesn't mean that we can able to program even many number of FPGAs with this particular software. Okay, so compared to this microcontrollers, FPGA both can be visualize your output. Doesn't mean that only microcontroller, like small project I want to do, I have to go for microcontroller like Arduino or Raspberry Pi. Doesn't mean that you can go for an FPGA. Even with the small type of programs you can able to implement. Even you can able to see there is a portable FPGA or small FPGAs are available in the market, which is very recently very good number of logic gates it has. Okay, and also that the input output power port and the timers which is having incorporated in the recent days. So it doesn't like that microcontroller only do have this timers and ADC modules, input output ports, something like now the FPGA which is dedicatedly made for the particular like Cyclone advanced versions. You have input outputs for timers, so external interconnects can be reduced. Like it doesn't need so many interconnects to be there to connect with the sensors. So in a real time you can able to connect with this FPGA with the very good speed with very high clocking speed, as well as you will get very high memory also. It is possible very recently. Okay. So as I told you earlier, it is having millions of logic gates. You can carry out the programming logic through the external peripheral. Also need an external peripheral for the functioning of the particular tool. So like it doesn't have the inbuilt display, or it doesn't have anything, or Wi-Fi module. So we have to connect some external peripherals for through the programming or BIOS connections. So the microcontroller can be programmed using C, C++, Python, which is as we know, we are programming using in Raspberry Pi or Arduino. But in FPGAs, we have to program using VHDL and Verilog program. Okay. So as I told you, compared to the microprocessor, FPGA have some limited space, especially the cache memories and those RAM memories are limited, like compared to the microprocessors, as I said. Okay. So as I told you earlier, the power consumptions of FPGAs compared to microcontrollers, they were not very high in domain, because FPGA consume with more power compared to even ASIC also. ASIC is basically made specifically for a particular applications, so doesn't need to think about what power consumption. Even a microcontroller recently, I told you, less than 1 microamp. So it consume in a sleep mode. Like if it is not consuming the power, the current will be even ideal conditions less than 1 microamps. I can able to wake up. For example, you can go for a latching application in industry, even go for a sensor in off time. So the sensor needs to be on. Doesn't mean that the sensor should be go off to save the power. Even if you put in that ideal mode, or maybe in the sleep mode, the sensor will be inactive. Like it consume 1 microamp power, so the battery power consumption will be very less. It is a very huge advantages over the FPGAs. It is a microcontrollers, you can go for such applications. So we can simply say that based on the application you can choose. If you want to do some many logical array applications, we go for many functions in that, many logical functions in that, and if you can go for FPGA, we'll go for a very small functions, or we can go for simple project just to have some specific applications. We can go for a microcontrollers. Okay, so it needs to have a JTAG, which is having an interface with the USB cable for programming this FPGA, and PCI to be attached for acceleration, similar to like GPU we have, and it is having a flexible and freedom for usage compared to the other memory devices. Okay, so now we come to the microcontroller programming, as I told you earlier. So I want to start with this Altair Embed. So this Altair Embed is software which is specifically designed to program this microcontroller based applications. So it doesn't mean that I have a Raspberry Pi, I have Arduino, I have some particular board. Many type of boards are compatible with this embed. So you can program this embedded logics in a real time. You can able to monitor it in the screen real time, and real time you can able to burn it in the hardware. It may be your Arduino or Raspberry Pi. So one of the very big advantages of Altair. So what is the advantages? You can able to save the time. So this is what embed, which is having a graphical environment. So it is a motor drive example they have shown. So you can able to see that output, like how it is going to be expected in the display. At the same time, I'm connecting the hardware, which I want to burn this particular program into that hardware. So doesn't mean that it have a n number of sensors, it have n number of interconnects, Wi-Fi module, other module. Any modules can be connected, like block diagram which were connected here. So it doesn't limit it for any number of hardwares. So you can connect any number of hardwares with this particular using this software, and you just choose what the processor you are using, microcontroller you are using, and you just burn it, and you can monitor it in the real time. So that is a very big advantages, which can able to save your time, and it can able to make your product output. Like you want to implement a product in a short time, so that might be possible with this tool, something like this one. So especially in the control of rapid development of control systems, this is very essentially needed. Like I want a high efficient diagram to code capability and real-time operating system. You can able to visualize the output in real time, and it can able to run very fast, and it is going to occupy low memory, because it is all made, the block diagram and interconnects are made in a real time. So no need to worry about the memory occupancy, and can able to easily debug. So human can able to debug very easily and it is very interactive with this our language HCL, and the parameter tuning with this system is also possible, and this gain of the system is data logging, buffering and digital scopes also possible, and the graphical editing also possible. Simulation is also possible, like doesn't need the hardware, I want to simulate it, I want to see only the graphical output, that is also possible, and auto scaling is also possible, and you can able to get the output very fast. So it will work like a loop chain, so like hardware in a loop, how it is connected, these will work like a loop chain, which I'll explain in you later. So what is the advantage is that there's no hand coding is required. Like if for example, I'll tell you, if a student is doing a project in an like water flow, so what he have to think is the timing is required. So he want to go for gardening or agriculture application. He will choose that Arduino board and he will buy some flow sensor or whatever maybe that flow sensor he will buy, and also he will buy for timers, and he'll go for some relay modules or relay sensors. So he has to write the program to first to connect with this timer in a real time with the hardware microcontrollers. So then according to the timer, that will control to the flow sensor, and the flow sensor has to be opened or closed according to the program he has written. So maybe he is connected to Wi-Fi, so that needs to be sent. So for all these things, he has to write the program for this timers. Again, he has to write the program for Wi-Fi module. Again, he has to write the program for interconnects. So this is a very messy and it is very time-consuming process, and it's very difficult to debug. Whatever error if he gets, there is a very difficult to debug it, and that problem can be solved if you go for such tools which we have in Altair Embed. Okay. So what is the advantage is you can go for what type of microcontroller you are using. So closed loop motor control, including PA microcontroller, digital output, PWM, encoder peripherals. So n number of operations, whatever can be inputted from this particular software. So that doesn't mean that it will have only limited inputs. You can have a number of inputs, encoding outputs you can able to get. So and the frequency and the memory footprint of this particular code also can be downloaded, and those data also can be downloaded, and this will also allow to work for a floating point code that is very essential for a automatic scaling. Okay. So this is one of the example I'm showing you, this called a digital power application. This is a PTD 08010, the digital power application board. So here what I'm connecting with this input with this particular block. So this is what PWM input I'm giving, and this is what a load active I'm connected. So these are the pin out. So in this place I'll choose this particular module in a software. So I'll run it. So according to that output which I get, so that output is get to load it, and function will be done. So for this, that doesn't need to write any program to be externally, or you have to doesn't need to write the program in between, or like separate programs doesn't need to be done. So this project, entire project can be easily completed with this particular tool. Okay. So so this particular software is supporting with this many number of hardwares like Amal, many number of microcontrollers it is supported. Even a reason microcontroller is also supported, and you can go for SPI, SA interfaces connectors, and I2C connectors, and digital GPIO connectors, and ECAP, ADC. These all connectors can be taken out from this particular software. Okay. That is one of the big advantages. I'll show one example how this is one of the application for motor control. So that PMAC motor control, which is in real time, you can able to monitor. Now this output is I have not connected, but still you can able to see what is going to be expected output. I can able to run the program. So very similarly, you can able to see the what are the number of hardwares it is supported. So this is Arduino Cortex M3. So these are that number of these are number of the hardwares, microcontrollers, which is supported by this particular software. So that this is very easy to do the programming. Doesn't mean that I'm showing the very complex example. So even like image processing, like computer vision, digital logic. So go for an machine control, electrical applications, whatever it may be, electronic applications. So anything can be done using the particular software. That is a very big advantage of the particular tool. Okay, and second one is, so till now we completed this microcontroller based program, so that can be done very easily with our software called Altair. So second one is coming to that FPGA program, which is called, we have the lab called SOPC lab, which is having a TOT with the CDAC Toronto. So with this one, we can able to make some system on chip development applications for a specific need. So for that, we'll also use the tool embed for this particular application along with this Quartus software. So Quartus is the software which is basically using to program this particular tool. Yeah, we are using a board called the Cyclone FPGA. So using this particular thing, we could able to make this. We can able to have this solar panel converters, power converters, controllers, a high resolution of oscilloscope, FPA function generators. So these are the tools we are using along with this tool to make the programming very efficiently. Okay, compared to this C++ programming, this is a VHDL and Verilog programming is also possible with this particular tool. Okay, so this is one of the Intel Cyclone board which is developed by CDAC, which is we are using for Cyclone 3 board applications, custom application developments. Okay, so the third part which I'm going to discuss here is PCB design. So PCB, here we have a very huge lab setup which is specifically for so the other two labs we are having in neighbor lab, which is not this particular lab. This for easy to explain, so we are explaining from here. So the PCB lab we have here is a real-time lab we are using from here for development. So PCB is something I have some idea in my mind. There is no way we can able to implement. It is very difficult to implement until you have some proper circuit design. So I can use microcontrollers, I can use FPGAs, but still my application is very specific and I especially need for the specific application, and I don't want to change it. I don't want to reprogram it. Like I want to do this hardware only for this particular application. So definitely there is a good choice of going for as a PCB tools. So PCB has to be start with some simulation. That is a very essential part. Unless you simulate your PCB or unless you test your circuit, it is very difficult for you to have some loss of your PCB, or maybe in the end product what you are getting may be wrong. So whatever you do the circuit, primary thing is we are using a simulation. So simulation you can go for, there are n number of software. So you have this multi-sim, there is circuit maker and Proteus, PSpice or LTSpice. You can go or model sim server visualization of the PSpice tools. So these tools can be used for a simulation of our circuit. Yes, now I 100% right. My circuit is fine. I can go for a PCB design. So then you go for a software called Eagle, or you can go for a Altium Designer, or you can go for EasyKT, EasyCAD. So whatever it may be the tool you can go for, is you can go for a design of the PCB. So whatever, so design PCBs that are designed to make custom design for the particular PCBs. Unless the circuit form, you're going for a design of the PCB form. Let big house into the circuit board. So PCB fabrication process, as you know, it is a very lengthy process in the industry. But when you fabricate a PCB in your laboratory, PCB fabrication process is something different, because we cannot able to adopt all the process which they have in the industry. Industry is established with millions of funding. So again, that is dedicatedly for the n number of productions. Like PCB is possible in industry, like you can go for industry level establishment, you go for 10, 20, 24 layer PCBs, 32 layer PCBs. That is very going for RF circuits, especially for space applications, radar applications. So according to that, like 5G communications, so the security you want, that efficiency you want, and the electromagnetic interference, less electromagnetic interference you want, you have to go for a high number of layer PCBs. So such PCBs you go, that is very difficult to make in the like in-house fabrication is not possible. It's not possible in the sense it is very difficult. So when you go for a PCB design in the laboratory, you can go for a single layer PCB or you can go for a double layer PCBs. So one of the two methods you can go for, one is called once the PCB design is done, we can go for a photoresistive PCB. So put a photoresistive layer on top of it. So then you can apply this UV exposure unit, which is called negative film. So I'll keep the negative film on the top of it. That is the mask which I have. So that the film is having the design what I want. That is the circuit design one. But there's a negative film. Okay. So means if these are traces, the negative part of the thing will be printed. So that will be kept on the top of this. then UV exposure light is given. So once the UV exposure light is given, so we need to go for a developer, which is missing here. So we need to put into developing solution. So it will develop it. Then you go for a muriatic acid, or you can go for ferrichlorate for etching. So then that process is completed. So copper will be removed. So the traces paths will be retained. So what really happens is the PCB will come. So what really then what you're going for is we can keep the what is stencils on top of it. Stencil means wherever the traces we have, or wherever this slots or whatever the traces we have, that part will be needs to be retained where we have to put the solder paste. So other parts needs to be hardened. Sorry, that part needs to be removed of etched off. The other part needs to be hardened. So what I will do is that stencil I will keep and I will put into this UV exposure unit. So that portion will be removed and the other portions will be hardened. So it will be hard, so that your copper will be safe and it is not going to be rusted, because of oxidation happens in the environment. Copper needs to be isolated, so that will be protected. So that this is a simple fabrication process. So when you go for a dual layer process, so there is a two thing. One is you have to go for you have to do the same process in the top, as well as you have to do the same process in the bottom. And very similarly in the bottom, some cases you will get this in dual layer PCBs you need to put this vias, because USB holder or the data connectors. So these things needs to be connected. It needs to be soldered on the bottom of the surface. So you need to go for wave soldering. So that is the best option, to solder the bottom of the surface of the components. So such once it is done, then you can go for a pick and place, like you can place the components where you want to. So sorry, you can apply the solder mask using the stencil. Then you can go for a pick and place the components, and you can put it in the like reflow oven. So reflow oven is instrument which is using to harden this solder paste as well as the component, as well as the holding part, like it is having the pads. So these three things will be sandwiched. So your final product will be ready. So now you can ask the question: it is reliable, or it is feasible, or it is advisable technique for an fabrication of a PCB compared to that you can order a PCB outside using it from an industry. So comparatively, I can say that that process will be, that is much more efficient, which is order from outside. That is a advisable one also. But when you go for a prototyping, like I don't want to fabricate, or I don't want to have a production lineup in the laboratory. Just I want to test my design. Like I want to just test the particular circuit in the laboratory. Then this is a very good advisable path. So what really happen is, especially if you are in a COVID, or if especially you are in a difficult period. So this particular technique will help you to make your in-house fabrication, but it's limited for 1 or 2 layers. So I will. This is a very easy process, like as I explained. But when you do it, it is not very easy process, like what I said. It need very good amount of patience. And you need to have a good negative film, because negative film is a very important thing when there is a very misaligned or any something small line of very small black mark will lead to have a circuit line in that, and your circuit will be shorted. So you should have a very good negative film, and you should have a very good photoresistive, and you should have a very good UV exposure unit. So these three if you have, certainly we can say your PCB will be very good. So PCB part will be done. Then according to the muriatic and ferrichlorate solution, so you can be able to get the amount of ferrichlorate you are using, the amount of muriatic acid you are using. So according to that, you can be able to develop the developing time you can adjust it. So that part can be done. So then UV exposure unit time is a very less consuming time. You can be able to make it very fast. Okay. So if that post PCB process, like once I made the PCB and like I have a stencil and I made this, I kept the stencil and I put the solder paste. So wherever the pads are there, solder paste are deposited. Okay, the resulting solder paste into pad will be like this. Then I go for a pick and place machine. So like in the pick and place, the machine will paste the leg of this on top of this paste pads wherever it's required. Then this same process can be done using the syringe also. In this, you take a syringe and you put some solder paste on top of it, inside that, and give small number of pressure if there is a small number of pad, and give large number of solder paste when there is a big number of big pad. So you have to keep in mind that you don't fill the pad because it may spill out, or it may have connection with the adjacent solder paste. So make sure that sufficient amount and quantity should be restricted, and it should be kept on the middle most often, not advisable to put on the above the traces which has. So, and also instead of pick and place, you can use this particular tool which is very cheap, and for 250-300 rupees you will get. It's a pneumatic one, you can click and you can place it manually. But for this, if you have a good mobile phone with the zoom in, that is fine. Doesn't need a high expensive pick and place machine for placing. So this will do your job. So these two will do your job of stenciling and pick and place process. Okay, so this is also possible. So some of the challenges when you go for such a low cost PCB fabrication process is bulging. So if you do excessive amount of solder paste, and once you done the reflow, or reflow in other words, you can do with sand, heating of a sand, you can kept on the board on top of it, it will do the reflow, or you kept on any iron box or some substances on top of it, you keep your board, it will do the reflow. So reflow can be done with many processes, but when there is excessive amount of soldering, so this bulging will happen. So what really happen, where the connection is required, will not be done. And when there is a like incapable amount, so you are not placed it properly, what really happen, it will get contacted with the adjacent pad. So when there is a misplacement, like in this capacitor, you see this pad is not filled. So this pad is filled. So there is a misplacement. What really happen is this is not connected. Okay. So subsequently it will affect your circuit also, because of this capacitor, what are the effects are coming, that will be affected. So that needs to be coming, it needs to be concentrated very well. And improper use of decoupling capacitors, that is also a problem, as I said earlier. And insufficient copper to edge clearance, that is a very big problem we are facing in the low cost PCB technology. But when you go for this stencil placement, it will be very clear. No need to worry about excessive placement of solder paste. No need to worry about whatever may be the amount I am connected. So that will be done. 90% of the pad will be taken into stencil, not 100%, so that you can place it very fine. So the pick and place will do place on top of it. No need to worry, because when you place with this one, it may be moved here and there. So because of that, solder paste will move up and down. So that problem can be avoided with this particular one. Okay. So when the challenges of this completed, so what we are going to see is this is one of the board which is called Arduino Mega 2560, which is developed using Eagle software. So this is a top layer which I shown here, which is this is a Mega controller 2560 microcontroller at Mega, and this is are the power handling units, and these are the bias which is there. So I will show you one example of only single layer board, which is using a laser engraver process instead of negative film process. So I'll show you how this process, with this we can able to make one single layer PCB. Okay, so this is a bottom layer. So anyhow, if you really make a dual layer PCB, you need these three things. One is a top layer, and another one is a bottom layer, and another one is a stencil layer. So these are the stencil layers. So you need to have a 1 mm thickness or 1.5 mm thickness stainless steel. With that you can make a stencil. So that stencil you kept on top of this layer, so they can apply the paste. So that is very important for etching of this photoresist also in the UV mask. Okay. So with this process, I want to start with this developing of top layer. So this flexible PCB part I will take once this process in on-go process, because this etching will take nearly 20 minutes. So meanwhile, we'll go to there and I'll show how the process will be done. So this is one of the laser engraver machine. So This is they call it as fiber engraver. So they especially used for milling, engraving, cutting. This process can be used. So also that we can use this machine for the etching also. Here I used one this resistive film on top of it. No, sorry, not resistive film, etching film solution. So I kept on this, and I this PCB design is a top PCB design which I shown earlier. So this top design I made for as an engraving file, because initially it will not be an engraving file. So I have to convert into engraving format. So I have to download it. And I have to make it into CAD format. Then I have to input from that format. It is called a EZB format. So then I make it as a red. So this red part is basically the area where you have to play, you have to do the engraving process. I hope this visible. Okay. So this red area is very important, especially doing for a dual layer PCBs. Especially when you go for dual layer PCB, you should be very clear the top and the bottom layers. Okay. Okay. So, so for single layer PCB, I don't think it is much important. So I kept it to that. Then I will go for setting. Regarding the settings, like I want to engrave this black area. So I kept this black is on, and so the loop count I want to make as 1. So the engraving process will be done one time. So speed will be like 500 mm per second. It will be on. So the power I kept 1. So 30 kilowatt laser means according to that the power will be taken. 30 watt may be taken or 3 watt may be taken. So the frequency I kept as 20 kilohertz. So of course, if you need more frequency, you need to have a more frequency. The pulse width index and TC start also I kept as 300, so that it is ideal condition. So it doesn't need very complicated measurement or parameters. So in this here, left side I have this 45-degree cross hatch. So the etching will be done in a cross format, like 45-degree angle. It will go from left to right as well as it will go from right to left, because I given the follower, and also I given the line spacing of 0.01 mm. So linearly it can say it is up to 10 microns. So each spacing it will go for measurement is up to 10 microns. Okay. So the hatch format I have given. So I enable this type. So the type of hatching will be in this format. So I start giving this marking. So hopefully you will see this marking in this page. So the etching of the top layer will be done using this. So better use safety goggles with this, because it may harmful your eyes also. Okay, fine. So hopefully we'll continue that until this process over. So this is the top layer which we are done now. So this process is going on. So bottom layer and the stencil layer can also be done, but it will take a bit long time because it itself take more than 20 minutes. So next thing is we'll be talking about the flexible PCBs. So flexible PCBs is basically it is come into market in the form of OLED displays, sensors, conductive inks. So you can make with these all these things, you can make a flexible PCBs. So OLEDs are the form of non-printed, and sensors in the form of printed also come, and conductive ink is also in the form of printed. So something like, imagine you have a circuit which is only printed on a paper. The paper is a conductive. Okay, so imagine a circuit is made on a paper. Your circuit is made on a flexible substrate, or circuit is made on a sheet. So you could imagine how efficiently you can make, how flexibly you can make your routine work. So that's what it is done using. Many industries are working on with, for especially for thin film application and thin film batteries, flexible batteries, especially for biomedical applications, reading of your diabetic, reading of your heart rate in a real time. So that sensor is placed on your body. So it hold on top of it, and it is much more flexible and doesn't need any external power supply, because battery itself a flexible one. So that is also possible with this printed circuits. So printed circuit uses an imprint technology, or when you make, we have to go for an imprint technology, because the imprint technology is one of the easiest technique you can make. You need to have an ink, and you need to have a extrusion based bioprinting also possible, inkjet based bioprinting also possible, laser assisted also possible. So extrusion based printing means you have to take a syringe and give a pressure wherever you want to have this traces. So that will be done. And inkjet printed means it is working with the piezoelectric actuators. So piezoelectric, you know, according to the frequency given, the pressure will be applied on the piezoelectric material. So it will generate vibrate, simply we can say. So for a resonant frequency. So according to that pressure it is given, the ink will be dropped onto the substrate. So it may be a polymer based ink we are using. So that is easily controllable. Like you can use like a printer, like regular printer is also used for a particular application. So in the area of ink cartridge, I'm removing it. So I'm refilling with this conductive ink, and I'm doing the process. That is the second type. That's called inkjet based bioprinting. And third one is a laser assisted. So laser assisted is having I have the absorbing layer and donor layer. Between I have this material. When the laser pulse is given, like when I give the PWM signals wherever it is applied, so according to that, the dropping of ink will be done. So it is more or like very similar to the process of inkjet printer, which is called bioprinting or piezoelectric printing process. So also you can do, that doesn't mean that you can print only that ink, you can print the polymer, you can print the cells, you can print many functional pesticides. That is also possible, especially it is very much useful in the tissue engineering process. And also you can design this glucose strip technology, like you want to make printing these electrodes. So you need to have a positive and negative electrode. Simply we can say is a positive and negative ink. So that I'm having a working electrode area, so I can able to make this electrode process with this external flexible circuit. Okay, so very similarly, this is one of the example of ink printed electrode, where it is working with these enzymes and getting reaction, and you can able to study this glucose, uricate, and the uric acid. So you imagine a ink printed one is able to measure these three in a real time. So like you can able to monitor a glucose level, you can able to monitor a uric acid, and you can able to monitor this lactate in a real time. Okay, so for this ink we are going for a graphene based ink. So graphene based ink is basically why it is preferable, because this ink is I can make this ink much more conductive, so that it is much more flexible, it is highly rigid, and this can be able to deposit on any substrate. So it is in the form of RGO we have to using for preparation of ink. So a modified Hammers method is used for preparing this RGO and synthesis process. So these are the steps for making this GO, and so I'm skipping this for a time process. So we go for a preparation of RGO. So RGO I am making is adding with ascorbic acid with reacting and reducing agent with the GO, and again I'm putting with this filter, because when you make a ink, so very importantly the cartridge, the ink should not be get disturbed in this nozzle, because when the ink nozzle is get stuck because of these particles from the ink, so the problem will come is the printing will not be linear, or it will get damaged. So what really need is we should have a fine porous material, liquid part with having good viscosity of ink. So that needs to be done, that will be done using this 0.2 micron to 2 micron filters. So that will have very good, and nanoparticle inks can be made. So that ink is very adhesive with any type of substrates, and that can be able to make very good conductive layers. So this is one of the material we made as a positive and negative. So this is how when this ink is dropped initially, how it is spread out. Okay, so this is a very simple normal printer, which is we can have a refill this cartridge, and with that we can make this flexible PCBs. These are also the circuits, because such circuit is also possible. Just we need to put this input and just print it. That's it. We can have a circuit. Whenever you want to place the component, or if there is an enzyme is printed, it will work like a sensor, like glucose sensor or uric sensor or whatever may be, according to that it will work. So as I told you, especially this technology is very useful in the area of bio hardware acquisitions, especially ECG, EEG, EMG signals getting. So you should not disturb the patient. You're able to monitor the data in a real time without any external, because it is really connected with the battery itself. Battery, as I told you, battery itself is a flexible one. You can get all the signals from the patient, even he is in a movement condition. So we need to have some calibration. That process will be done using the acquisition hardware signals. Okay, and the last part, which is I am discussing here, is a optical lab. So this optics lab, we have this pesticide detections. Optics lab is processed with you know, the pesticide is most commonly used in the tea production area in this agriculture marketing. So it is so tough to identify this type of pesticide you are using, because most of them are adhesive pesticides. And second thing is, the pesticide will not be applied on the linearly on the areas. It will be some part it will be applied, in some part it may not be applied. So while testing, we have to make the random test, the random portions in that agriculture product or in that tea leaves to get the process. So for that, for efficient analysis, we are using the technique called grinding, ultrasonification, centrifugation, extraction. Then you go for this process called SERS, the surface enhanced Raman spectroscopy. So this SERS plays very big important role in the study of this pesticide detection tools. So the tools we are using for this is a laser source, ultrasonicators, laser controlled PCB, and Raman filter, centrifugation, extraction, and spectroscopy. So this is one of the development of portable spectroscopy project is done by our BTech student last year. So they used OPU based tools, that is that optical pickup unit, for this particular application. So with this spectrometer and collimator lens, with the laser source of with OD6 filter 12.5 mm is the Raman X filter they are using to pass the wavelength above the particular range. Yes, above the 532 nanometers. So with this resolution of plus or minus 10, you can be able to get with this filter, and we are powering this laser with 50 milliwatt. So optical fiber cable is 200 micron core is used for particular applications. So this is what one of the example is done in our laboratory by our BTech students for studying of chemical compound as well as pesticides. So this glass tab is having a pesticides or a compound which you want to study, and this the resonant wavelength is studied. So according to the peak wavelength, we are getting to conclusion that, so according to the absorption also, we get to conclude that what type of component which is there present in the particular particular sample. So this is not only for pesticide, it can be also used for analyzing the component within the range where you want to study. So one of the advantages, we can able to study acetone, toluene, naphthalene, as well as some of the pesticide components also. So this design is very cheap and very simple and very efficient, which could able to done it. So with this one, we could make this was one of the result we get from this spectroscopy, which is acetone. So we found the Raman shift in the ranges of 790 and 1710 and 2926, which is having a difference with this conventional 1:1:1. So this is what measured ethyl alcohol, which is having a measurement of 880 and 1280 and 1460 peaks, which is having a difference of 2, 1 and 3. And this is of naphthalene, which will show very good results density when you measure. So which I could able to measure is a 1024 and 2250 and 2600 and 3058, which is having very small difference shift. So this is basically a found Raman shift, which is a industry grade measurement from the journals. This is what shift we already get from our results. So this is what spectrum of naphthalene, which we get measured one, which is a result of intensity versus wavelength, to get very accurate results. Otherwise, when you see the graph, will not be look like linear. So it will get that very linearized curve. So we'll get 560, 575, and 605. So this low cost system, this is a chloro 5-phos, and that is a weedicide. So this pesticide is very efficiently detected using this particular technique, but the resultant is not up to the mark, but still we could able to get some of the peak intensity is around the ranges of 626 and 115, 1155 and 1553. So some of the results are coinciding with this one. So these needs to be addressed. It's a very good work done by us. This is a glyphosate, which is a spectrum, which we could able to get majority of the results as a matching with the industry grade one. And some of the students availed this support from KTU, and he plays in Intel and in this particular lab, and we are working with Pushpagiri and SMITs. So now I will show that PCB, which we already given. So let me proceed with the process of PCB, and I'll explain the next process of etching from now onwards. To 10 minutes. So here, what very important thing when you do this etching process, the color code which we are choosing should be very important, and keep the color code on. And if, for example, in this diagram, I'm making this black as a engraving area. So the black is a pen I keep as on. So the white is a non-engraved area. I don't want to engrave it, so I get white as off in this one. So I doesn't need done anything for white. So I kept black as on. So the black area will be engraved. The other areas will not be engraved, so that you will get the decide pattern in this particular circuit. Okay. And also I have to look into this pen I am choosing. So here there are different colors I have. This is the blue color, the red colors, this green color. So this doesn't mean that you have to choose what color you want to engrave. So I make the pen as black here, so that the black only will be engraved, the other part will not be engraved. So the other pens will not be active, we can say. So the other measurements or other engraving I have not done anything. Okay. So again, the position is very, very important when you're going for a dual layer PCBs, because when you go for dual layer PCBs, the best suggestion is to go to start with 0 and why to start with 0. And this size is as per your PCB you have, that will automatically come when you do such alignment. So you place the PCB at the edge, corner edge of the area, so that you get the desired output. And when you going for a holes you are making, but when you give them bias in these areas, always you do this same calibration. For example, what if you do the same calibration measurement in the top side, in the bottom side, what you have to do, that shifting, because when you rotate the board in the back side, what really happens is the left side will print on the right side. because the top area will be tilted. In reality, we can see. So make sure that you 90-degree rotated the board, 180-degree you tilted this design, so that the desired part will be coming to the left side. So again, this position you don't change, you always keep it as a 0, 0 and the desired value. So whenever you do this, so the particular alignment will come to the desired point. So the process will get done. Very similar process you have to do for that drilling also, because when you do the drilling process, laser drilling will be much more accurate as compared to the CNC drilling. So most often I will do the drilling process with laser only. So laser will do any type of drilling. For example, some vias will be for 0.3 mm, some vias will be for 0.5 mm, some vias will be for 1 mm, some vias will be for 3 mm. Even for corner vias, you can go up to 3 mm. So that is as per the design rules we can go. But only thing is, I'm not limited for the vias. So the size of the vias is not limited. So with this laser, I can even go for a 0.3 mm vias. The trace clearance also, I hope many of you are aware of it. So the trace should be 0.3 mm, the width of the trace, and the distance between adjacent traces should be 0.3 mm. And there are some more measures you should be very careful when you design this circuit. That is, these parts we cannot be doing here. We have to be concentrated when you do the circuit part. Okay. So when you concentrate the circuit part, you should be very clear. The design rules are followed. Unless what really happen is there will be interference of will be getting the interference of signal, especially if you go for low frequency devices. If you want to design, especially like frequency like Arduino board or something, you will not get much problem. There is a low power devices, there is no problem. When you go for buck converters, when you go for a very high frequency signal like RF signal devices, RF design I want to do, then such things we should be concentrated. The design methodology, multi-layer. So those needs to keep in mind when you go for high frequency or RF design. So these are some of the options which is for once you import the device. So some editing part needs to be done to make it is for alignment and the number of engraving areas. For example, within a 1 mm area, how much engraving line needs to be done. So that part needs to be given, and what resolution you want, that needs to be given, and line spacing what you want according to this, and those settings can be done using this particular these settings. So because it is going on, I am able to edit it. So I'm just showing it how it is. So this is a red mark, which is basically to show the area where it's going to be marked. Something like if I click the red, it will show your desired area of marking is this one. So you can able to easily understand it is not going beyond my expectation, especially when you go for a dual layer board. That marking area should be within a range. It is not out of the scope, unless what really happens is your alignment will get misaligned. So when you go for a vias, the top and bottom will not be connected. So the problem will come. So more often we'll use this design for an specific applications. For example, like we are working for this hydroponics and where also we are working for a watering plant. So for such boards development, we are working on this tools, PCB fabrication tools. So gradually we are, because of a DTech project, it is ideally good, but it is time-consuming process to design one board. So if a student is come with a PCB design, then things will be much easier for us to do. If a student is wanted to get to done the PCB design, then we have to go for a designing process as well as the PCB making. So again, it is limited with the to a dual layer. So we always suggest for making this 2-layer PCB and test it. If really fine, the product is outcome is good. Then if we really want to make more number of products, then go for an industry level. So one of the advantages, the output come will be very fast. You can make it ready in very short time. So altogether, I think this process will take 3 hours to make one PCB. The time consumption will be limited in the laser area only, and as well as etching area, because etching you can able to manage with more number of trays, and UV exposure also we can make, but the limited or the viewing area is basically the laser areas. So probably in 3 hours you can make even 5 to 6 number of boards expected to be, because each board will take for this take 20 minutes. So in backside it will take another 20, because backside I hopefully you know that there are not more number of traces will be there. Whatever the wires are there, according to that back traces will be followed. So that is one of the interesting method where we can adopt for our fabrications. Again, the one more thing is there is a fume extractor needs to be connected, because you know these fumes are really harmful. So backside fume extractor is the protection we need to have, and again the glass needs to be raised to be protected when you are handling with the laser, and power needs to be controlled. Power controlling is very important, because if you keep the 100% power, and that will cut the board itself. It will cut the board into two pieces. Instead, it is engraved. Okay. So again, a movement of hands here and there, it is also a very dangerous one. So unless if you, without knowingly you move your hand, you cut your hands. So the safety is very important whenever you go with this type of design. So secondly, you can ask why you not didn't go for this UV exposure method. Yes, UV exposure method is very good, but when you go for UV exposure method, you need to prepare a negative film. For negative film, very difficult to get the good printing, because you know when the circuit is a small circuit, or whenever the circuit spaces are very big and it is having a huge number of gaps, things are very easy. Yes, you can understand, but when the circuit in between the traces are very small, and that QPIC is IC, what type of IC you are using, and that FPGA ICs we are using, or sensor ICs you are using, which are using IC. So some of the ICs having like 200, more than 200 parts are there. So such parts, microcontrollers, if you go, so you need to have very good resolution film. So to get that film done, it is a difficult process. So again, we have to go for a photoresist. Again, that is an additional expenditure thing which will be added in this one. So comparatively, this process is cheaper and efficient and easy to do, and less time consuming, with some safety precautions. So along with this, after this process, then we have to go for etching of this board. So that after developing, we have to go for stencil making. So that is a UV exposure unit. So then after UV exposure unit, then we have to go for solder paste application. After solder paste application, you have to go for pick and place. After pick and place, you have to go for reflow. So this is a circle process to make a PCB, complete PCB. So because of time limitation, I am limiting with a single layer structure development and etching. So the other part of the machines I will show you and explain once this process is completed. hopefully very important thing is the scale is very important. So what scale you are keeping? So it is in inch or it is in mm. So according to that, this design will come. So if you are most often we are use centimeter design or inch design. So make sure what scale you are choosing should be matches. Unless what really happens is uh, your board will come into very small scale when you go for a firing. So you should be very aware the x and y values of the scale. So keep this value. Unable to edit it because they are running. I'll do one thing. I will show this board on camera so that you can able to see the developed traces very clearly. Once this process is completed, I will show it on camera. So hopefully it took this much time, nearly 30 minutes it took for developed in one side. Traces. This is IC, this is Admega IC which I shown on the circuit. So this is power IC legs, and these are the traces which is developed. These are the vias, which is so this is this top and bottom. So these are the measurement vias, the corner vias, which is so in between. So in these vias we have to make these holes. So with these holes, they has to come down. In the bottom layer, once you develop the bottom, you can make the vias. It is a very easy process. So you could be able to see there is no shorting between the legs. It is very small difference. So hopefully, I think it is a 0.2 to 0.3 mm difference between the legs of IC. Okay. So still there is no traces you could find, no shorting or no connection between two traces. So hopefully you could say that this developed film is much more efficient. Okay, so the accuracy will be very good compared to this other film. So unless the photoresistive method, because unless in the photoresistive method, what happens if something is lost, then you have to draw it with the pen. Then you have to go for development. So in this, such things can be avoided. Okay, fine. So this is a top layer which I shown on the, which is developed. Okay. So now I am going to put into this developer solution. So I'll put in the developer solution. So it will take around 20 minutes for developing. Okay. So by the time I will explain the other tools, whatever it is, because it's very difficult to cover within a time. So this is This is an UV exposure unit. This is basically for a flexible piece. Okay. So this is a UV exposure unit. So it should not be you should not see it with the physical eye because it is very harmful. So this is basically using for a development. Okay. So it endanger your eyes. So once it is done, what really happens? We have a stencil. So the stencil will kept on top of it. So that is no, sorry, they will apply this solder mask. So this mask apply. So on top of it, I'll apply this stencil, keep the stencil. So I'll give for dry for again 15 minutes. Then it will be developed. The traces areas will be removed. The other areas will be kept. So more often we will use this light for while doing the development process because it will not etch off your board. It will safeguard your because it's yellow lamp, so it will be safer. After that, you have to come to this area. This is called the stencil printer. So what really happens? This is one of the demo board. So this I'll keep it and I'll apply. I'll tight it. Then I'll apply the keep the stencil and apply the solder paste. Okay. So solder paste will be applied on the pads wherever this you could be able to see something like. So wherever the IC pad, solder paste will be applied. So then what I will do, so after applying this solder paste, so I'll reduce this tin because already tin is applied. So you can bring it down. So I'll keep it on the pick and place machine. Okay, so this is what pick and place machine. So the machine is loaded with this ICs, the reels and also loaded. So when I do this, it's computerly connected. When once I input the design of pick and place file, so that will be taken. So according to that, the component will be placed. So according wherever you want to place the components, in the particular area you can place exactly in the solder paste area. Once it is done, what I'll do is I'll bring it to here. So this is called a reflow oven. So reflow oven usually for a development of this. This is addition of solder paste with the pads. So reflow oven is basically very important. The difference between this heating element and reflow oven is the temperature increment within a short time. So you're able to see attainment of temperature of 280 degrees centigrade at just 4 seconds, and again decrease. This is, you can say, this is a type of wave soldering. I hope you can able to see this. Okay. So this type of soldering is possible with this reflow oven. So again, I set the speed of the reflow oven according to the requirement. So if I keep it high speed, conveyor will move much faster. So keep it according to that. So according to the board, what type of board you are using and what type of solder paste you are using and what type of material developed. So everything will be considered when you put into the reflow one. So in the reflow one, this I kept in this side, so it will come on the other side. Anyhow, this is not required because there is no component is placed in this one. Okay. So once the outcome I am getting this board, my final board is ready, the product is ready, because even you do the board from outside, this we can place and reflow process and stenciling needs to be done by yourself only. Okay, so this cannot be avoided. So then especially this instrument I'll be using for this is called Hall effect measurement. Most probably many of you are aware of it. So when I'm doing the sample study, like when I'm preparing like graphene material or any conductive material solution, so I have to calibrate, I have to measure it whether this is really conducting, and I'll keep the sample here and I'll place it. And I could be able to measure the two things. One is called mobility, and I can also be able to measure with that I can be able to measure the conductivity of the material which I prepare. Okay. So that is possible with this particular Hall effect setup because it is electromagnetic measurement, and this constant power supply is given when a conductor is placed in a magnetic field. So the proportional voltage developed will be studied here. So that is with using the constant current source, microvoltmeter and gas meter to be able to do the measurement, and the calibrated value is taken and plotted. So that is very important. And another one is nano voltmeter. So nano voltmeter is basically used for a biological study. So this is one of the nano voltmeters. So when you study this microvolt range, especially a conductive film, you want to study really conductive material, so you can able to do it. Very similarly, the film what you develop or graphene, whatever may be the biological signal what you are getting is in the nanovolt range or not. So the nanovolt measurement can be done. So this is that possible can be done with this levels. Fine. So the other testing elements we can use is oscilloscope, so that to test the traces and the signals and frequency. So those parts can be done. So regarding this development solutions, you can go with this. This is a photoresist developers, and this is a liquid photoresist, and this is a blue dye, which will be applied, and this is a. So whenever you use this, you have to be very careful with the solution, because here, and the safety is very important when you handle such chemicals. So the imprinting we have done using this. This is a normal printer. This is not something very complicated printers. So when you do such process, so this is sufficient for your. Yes. Okay, so again, I forgot to tell about this IC. This is a ADS1299. This is having a 16 channel. A single IC can able to provide 16 channel output. So that is very important for you to study this EEG, CG, EMG, and EOG signals. So this is one of the hardware you can able to make even with flexible or non-flexible ICs, and especially for biomedical study. This is very useful, especially this now one ADS1299 is a microcontroller. This is not idle microcontroller. This is an ADC module. This is having an 8 channel and 16 channel models we have. So those development also we are working on for developing a shield based portable microcontrollers, and with the Arduino microcontrollers, because making a microcontroller needs to be flexible. That is another challenging. Not only the channel based needs to be flexible, hardware also needs to be flexible. So we are working on that also, and also we are working on this wireless battery or the flexible batteries, which is very useful for you to make especially biosignal characterization or biosignal calibration, which is very important. If anybody want to ask any doubts, you can ask me. And one more thing, when you go for PCB fabrication process, make sure that you have photoresistive material. Whatever you are using is a good quality photoresistive, because what really happen is when you buy a low quality photoresistive, the development will not be linear. And in some people will use this heating method, which is fixing of this ink on top of the this pad. Again you go for a development, but it is very good. It is not really bad, we can say. But when you go for a complex circuit, something like this, when you go for it, you need to have some good resolution, because anything wrong happen in the traces or anything wrong happen in between will make your board entirely lost. Especially in the IC pads, anything is gone. Again, the spacing between the pads is very small, as I told you earlier. So it needs to be much more concentrated what type of thing you are using, material you are using for fabrication. So that itself matters. So again, you can also go for a prototyper. There is an instrument called prototyper. I hope you will be aware of it. So prototyper will do this engrave process with the spindle, with the needle. So with that, by rotating it, you can able to make the board, but it will also take very long time compared to this one. Itself, I think this dual layer will take around 40 minutes or 50 minutes. So that itself take more than 1.5 hours. Again, what really happen is it will not clearly remove when the spacing, because if the spacing is very small, the resolution will not be very good. You will get, for example, less than 0.3 mm or near to 0.3 mm. It's very difficult to attain unless you have very good quality of prototypers, which will be very expensive. So that also needs to be concentrated when you go for a PCB design. Again, design methodology. So design methodology is very important. Like especially go for dual layer, and also you can go for multi layers. So above that you can go for 4-layer board. So, but still that is not really easy to make it in a laboratories like this one. So such things you have to go for a like industries. Like industry, we have PCB waste. Many industries have fabrication of PCBs. Okay. So how can we study the process of PCB printing? So for PCB printing process, recently PCB printing technique basically not using for a flexible PCBs. Normal PCB printing is rarely used. There are one of the prototyper machine is using PCB printing process, but it is not much more relevant. So for a flexible PCB thing, you can go study the PCB printing process. There are many textbooks are there for PCB printing technique or technology. There are no courses like they are offering for like PCB printing. There are the printing material printing is there, so that you can just using for a biomedical application like DNA and the structure development and tissue engineering. So there is a printing called material printing. So that compared to the both are not much more different. So we can say that PCB that is a material type of printing we are using. This is a ink material we are using for development. That's it. Yeah, there is no, I cannot say there is a specific course there is for PCB printing. There is a offering like for specifically for PCB printing. So what we can do is we can train PCB printing in our laboratory. So what really we are doing is we can make PCB ink here. We can give the training on PCB development in our laboratory, but there is no like BSc, MSc courses. There is no specific degree courses for in this PCB printing. There is a training programs we are offering for PCB printing. Okay, so if there is no questions, then we'll look into our code. So I believe you'll be able to see this. So on that black color is basically that etching solution. If you use acetone, you can able to remove that black color. Basically, it is an ink solution. So and below that, there will be a copper traces. Hope you understand. See, there is a copper, and below that. So you can use acetone for removing this black etching solutions. You wipe off with acetone. So yeah, PC that. So how can we get these details of the training? So I'll share the details with you. If you share with the team of organizing, I'll share the details about this training program. Side, so as he told you, the programming side of especially firmware development. So that is we are doing with Altair, because Altair is somewhat very easy. So I'll share the compatible hardwares with Altair. See, these are that microcontrollers are supported by Altair Mbed. So doesn't mean that it needs to be Arduino. So these are real-time control boards, performance microcontroller ICs. So again, these are the control and automation ICs, and these are the ultra low power microcontroller units. And these are the ultra low power microcontrollers, microcontroller ICs. And these are STM microcontrollers, basically called mainstream microcontrollers, which is high performing microcontrollers. STM32 microcontrollers. So why you need these microcontroller ICs? Because you need very specific application. You want to make some board specifically for, even you can make Arduino board, you can make Raspberry Pi, you can make any boards. So they have some specific STM32 mega microcontrollers. So there are many type of microcontrollers you have. So you can make some microcontroller for video editing, some microcontroller for RAM, some microcontroller for. So what microcontroller are you choosing? Some microcontrollers working for ultra low power, so that you can able to make very efficient and a long duration possible sensors, especially for remote sensors. It need power handling capacity. So you choose the microcontroller such that so that it will fit for your applications. These are some mainstream microcontrollers are supported, and these are the high performance microcontroller from STM32. So these are the new microcontrollers supported with this software. And according to the commercial boards, there is a Raspberry Pi is supported with this Altair. Raspberry 0, 0W, 1A plus B plus B, 3A plus 3B plus 3B, 4B. These models are supported, and AMD 64 is not supported. Again, in case of Arduino board, there is a Mega 2560 UNO, and Leonardo is currently supported. That means that you can make it to work different boards with the supporting drivers. I checked with the other board also. It will work, but the supporting drivers needs to be installed. And again, you need to be much aware about this interconnects. The microcontroller that I've been a board here using that here and make it work. Told you we can make a framework for the programming, that is the development for you can go for VHDL using Intel software. With the display. So if you want to display, you have to go for custom firmware development. So the depth firmware development is a bit difficult, but still it will make enough for you to go for an industry. So that level of is very
Sir, you're actually on mute. So കേൾക്കത്തില്ല പറയുന്നത്.
hello. Okay. If there is no more question, we can wind up.
Thank you, sir. Thank you, sir, for sharing your knowledge and insights with us. I hope the participants does not have any more questions. Thank you, sir. And we've reached the end of our second day. For the third day being tomorrow, we have session organized for the topic automotive electronics and engine dismantling. Hoping to see the same participation and cooperation tomorrow as well. The team of IEDC AGC would like to thank all of you. Thank you to our esteemed speaker, Dr. Godwin Raj. Thank you, sir, for sharing your insights with us today. I hope the session was really incredible for the participants. Lastly, note of gratitude to our participants for their enthusiasm and cooperation shown. Expressing sincere gratitude to each of you. Thank you for making this event a virtual success. Thank you. I request the participants to fill out the feedback form before leaving. Thank you.
Thank you. Thank you.